Hello all. In today's video, I wanted to discuss about looking permutation as a function and also decomposing a permutation into independent or disjoint cycles. This will really help your problem solving and your mental ability of perceiving permutations. This is also involved in permutation groups. If you are interested, you can look into the group theory and permutation groups essay. Let's get started. Suppose you consider 5 numbers 1, 2, 3, 4, 5. You want to do some permutation. What is a permutation? It just means some rearrangement of these numbers. Let's say you do 4, 2, 1, 5, 3. Then we write this permutation as a function from this set to this set. That is, sigma of 1 equal 4, sigma of 2 equal 2, because 1 is occupied by 4, 2 is occupied by 2, 3 is occupied by 1. So 3's position is occupied by 1. 4's position is occupied by 5. So we write sigma of 4 equal 5. And 5 position by 3. So sigma of 5 equal 3. This is the functional representation of a permutation that's given. You can write like this for any given permutation. Just make this as the input and this will be the output. How to decompose, or what are cycles involved here? Sigma is a function from the set 1, 2, 3, 4, 5 to itself. 1, 2, 3, 4, 5. Each map gives you a permutation. 1 will have 5 possibilities, 2 will have 4 possibilities, because this map is bijective. This map is bijective. So 1 can take any of these 5, 2 will take the remaining 4, 3 can take any of the remaining 3, 4 can take remaining 2, 5 will take the remaining 1. So it's 5 into 4 into 3 into 2 into 1, which is 5 factorial, and that's 120. That's why we say n factorial as the number of possible permutations of numbers from 1 to n. And here we take from 1 to 5, and there are 120 possible functions. This is one of those 120 functions. Alright, what are cycles here? You see, 1 goes to 4. I mean, the place 1 is occupied by 4. Or when you apply sigma to 1, it takes you to 4. And when you apply sigma to 4, it takes you to 5. And when sigma applied to 5, it takes you to 3. And from 3, you map back to 1. So you get a nice cycle, isn't it? And what about the number 2? 2 is not here. 2 is actually mapping to itself. This is called one cycle. This is called as a one cycle. And this is called as a 4 cycle because of its length. It's 4 in length. Therefore, you can also write the permutation sigma as 1, 4, 5, 3. 5 goes to 3. So sigma of 5 is 3. That's the meaning. Each is obtained by applying sigma to it. And then the one cycle is written as just the number itself. Writing this way is sort of decomposing it by cycles. It always need not have this form. It can also have like 2 cycle and a 3 cycle, or entire 5 cycle. Let's consider the permutation like this. Consider another permutation pi, which goes like 2, 3, 4, 5 and 1. What does this give? What does this give? So the position 1 is occupied by 2, that is pi of 1 equal 2, and the position 2 is occupied by 3, so pi of 2 is 3, and the position 3 is occupied by 4 and 4 by 5, and the fifth position is occupied by 1, so we write pi of 5 equal 1. So 1 goes to 2, 2 goes to 3. Goes to just means the function pi is applied. So pi of 2 is 3, pi of 3 is 4, pi of 4 is 5, and pi of 5 is 1. So this is a 5 cycle. This is a 5 cycle, and hence you can represent pi as just 1, 2, 3, 4, 5. Likewise, you can represent every permutation, every 120 of those in a unique way. Why is it unique? Because given this cycle, you can determine this permutation, and given this permutation, you know how the rearrangement is done because you know the value given any placeholder value. Moreover, the total number of numbers in all the cycles add up to 5. If you have any number n, in general, it will add up to n because each value is a part of our domain under consideration. So everything must occur and exactly once, because if 4 goes to 5, then you cannot have 4 going to some other value. It must be 5 here. So this is something interesting about this. Moreover, why is it not forming a cycle like this? Why is it not ending up here? Because this value over here, let's say, is some t, and this value is s here. Over here, the preimage of s has two values, one over here and another here, which gives a contradiction because our considered function or permutation is a bijective map. But two values here are mapping to the same s, which is not injective, so leading to a contradiction. As an exercise, let me give you a permutation pi 1 that looks like this. Of the numbers 7, you have the permutation like 3, 4, 7, 2, 5, 1 and 6. This is the given permutation. Can you write or express this in terms of cycles? Just arrange all the cycles, club them together and represent it here in the way we represented the other permutations. This will be really helpful in problem solving. In fact, in SuMON, we incorporated such problems recently in the level 3, where we give worksheets to students of grade 7 and above. If you find it useful, you can also try our free trial worksheet at www.sumonman.com. See you all in the next video. Thank you for watching, everyone. Bye.